Alright students, in this video I'm going to go over the questions in parts for the fall semester exam that we have. This is in different units, so unit 5 is going to be the first video, front and back of this paper or this packet. And then unit 4, unit 3, unit 2, and unit 1 will be in different videos as well. Alright, so the first question here we have that the ratio of the measures of the angles in a triangle is 8:3:4. Find the measures of the angles. When we learned this topic, we had to use that ratio and interpret that we have something times 8 plus something times 3 plus something times 4, and all of the angles together will equal 180 degrees. So that x will represent that something that they all have in common. Next, we're going to combine like terms, and that will give you 15x. And then next we solve for x. So we divide by 15 and we get x equals 12. This x is not the answer to the question. X will give us how to now find the angles, the measures of the angles. So we have the first angle being represented by 8x. So we're going to do 8 times 12. The next angle we have 3 times x. So it's 3 times 12. And the third angle will be 4 times x, so 4 times 12. The answers to these will be 96 degrees for one angle, 36 degrees for the other angle, and 48 degrees for the angle. So these three angles added together equal the 180, forming that triangle. And that's how you answer that question. All right, let's move to this question now. The triangles below are similar, and the perimeter of triangle B is 52 feet. What is the perimeter of triangle A? So they're giving you triangle B. They're telling you that the whole perimeter for this is 52. It's the perimeter. Then what they want to know is, what is the perimeter for triangle A? Well, we don't know the other sides, but we do know these sides right here. These are corresponding sides. And when you have corresponding sides, you can make a ratio. So we can write the ratio as 9:30. And we don't know the perimeter, but the perimeter also follows proportionally. If we do 9:30, then we got to do this missing perimeter with this given perimeter. So we're going to write x over 52. Here we're going to cross multiply. We're going to have 9 times 52 equals 30 times x. 9 times 52 gives you 468. And now we divide by 30, and x equals 15.6 feet. As you go through this video, if you want to solve the problems yourself, pause the video, do the work, and then just press play when you want to check that you did it correctly. All right, the next part, we have a triangle CDE, similar to WXY. So they're telling you that it's similar. So you got to find those corresponding sides. This side will correspond to this side because CD are the first two letters, and the first two letters over here are WX. And if you want to color coordinate, you can do DE, next two letters, XY. And then obviously that third side is the other similar one. So what they're saying is that the scale factor from one to the other is 4:3. So we're going to write 4:3. And then they're saying that find the perimeter of WXY. There's several ways of doing this. You can either find what the new side lengths are, or we can find the perimeter right now for this, and then we can write a proportion like we did previously over here. So let's do that. Let's find the perimeter for what you already have. You have 13 plus 29 plus 22, and that's going to give you the perimeter of 64. So if this perimeter is 64, this is the one we don't know. And if we're going to compare side by side, we're going to say this 4:3 is going to be 64 to x. Now it's hard to tell where to put the 64, but if you look at the images, this is the larger triangle compared to this one. So therefore, the largest will be 4, and the smallest will be 3. So we'd go large to small, large to small. All right, so 3 times 64 equals 4 times x. When you cross multiply and divide, you get 192 equals 4x. Divide by 4, x equals 48. So that x is the perimeter that they're asking for. The perimeter of 48. All right, the next question says two similar rectangles have a scale factor of 2 to 7. The perimeter of the largest rectangle is 35 inches. And what is the perimeter for the smallest? On this one, they're not giving you any sketches, so you might as well draw your sketch. You have a large rectangle, and you have a smaller rectangle. And then it says that the scale is from 2 to 7. So we're going to do 2 being the smallest, 7 being the largest. Then it says the perimeter of the largest rectangle is 35. The largest rectangle here is 35. And they're asking for the perimeter of the smaller rectangle. So the perimeter here, or the proportion that we could write, could be using the 2 to 7 equals, and then if we look at the perimeters, 2 is the smaller rectangle, and 7 is the largest. So we're going to do the perimeter of 35 right here at the bottom, because that's for the largest, and when we don't know the smallest. Again, there are other ways of writing this proportion. There's many, many ways. So as long as you cross multiply and you end up doing 2 times 35 equals 7x, you'll be okay. So 2 times 35 will be 70. And then if you divide by 7, you get 10. So the perimeter for the smaller rectangle is 10. All right, let's look at the next question. We have, what are the proportions of the sides of AMN and triangle ABC? So if we color coordinate or if we annotate, we have AM, and it's going to be the first two letters, so the first two letters AB. And then we have MN, this part, and then BC, this part. Okay, and then the other side, this part right here will be to the whole third side of the big triangle. So we're going to write them like this, and they could be different ways as long as you match them accurately. For example, we're going to do AM. So this little part right here, it's going to relate to, or it's going to be proportional, corresponding to AB. So we're going from small to big. The next part I will say is AN, this little part, to the big part. So we're going to do AC. And then the little part, MN, to the big part, BC. So this is one way of writing it. There's different ways. Next one, we have a solve for x, and they're telling you that these are parallel with these little arrow annotations. So you just do the part to part. Here, keeping in mind that 28 is given, so we're missing this little part right here. But 21 plus 7 is 28. You could do the annotation here if you need to find that difference of how we got 7. And then now we do a proportion. We're going to do x to 18. So this part to this part equals, and we're going to do 7 to 21. And you cross multiply, so 18 times 7 equals 21x. 18 times 7 will be 126. And then when we divide by 21, x equals 6. And like I said, pause the video, do the work, then press play and check if you did it correctly. Okay, in the back we have this question right here. This one says triangle JKL is similar to NML. So when they tell you that, follow the order. JK, similar to NM. So JK, similar to NM. And then you have KL, KL, similar to ML. And then you're going to have JL, this part, similar to NL. Find the values of x and y. So here you want to make a proportion for the x. The x is right here. So we're going to use purple, purple. So x to 14. And then we're going to compare it to a ratio that is already filled in. So we don't want to use the pink part here, the y and the 45. We want to use the blue, the 40 and the 16. But it has to go in the correct order. So x to 14, we're going from big to small. And then we're going to go from big to small. So we're going to do 40 to 16. So that will help us out for x. For the y, we're going to do y to 45. And it could be written differently. It's just the way I'm writing it on this example. So y to 45, this one I'm going from small piece to big piece. So small to big. And then on the other part, I'm going to write 16 and 40, going from small to big. So 16 to 40. So this proportion will help me with the y. This proportion will help me with the x. Pause the video and try it on your own, and then press play when you're ready. So we have 14 times 40 equals 16x. 14 times 40 will give you 560. Then you divide by 16 and x equals 35. On this part over here, we're going to multiply 45 times 16 equals 40y. 45 times 16 will give you 720. And then you divide by 40, and y equals 18. Okay, let's look at the next problem. We have, if these are similar, KMZ with KDH. If they're not annotated that they're parallel lines right here, don't assume that. Make sure you draw them separately and label them. That could help you a little bit better. So the small one here, I'm going to label it x and 32. And the big one, I need to understand that it's the whole thing. So it's going to be x plus 21. And then this is going to be the whole thing, all this. So it's going to be 32 plus 28. And that's going to give you 60. So now we will write a proportion for that. We could write x to 32 equals x plus 21 over 60. Cross multiply. 32 times x plus 21 equals 60 times x. Distribute. So we're going to have 32x plus, let me calculate that real quick. So we have 32 times 21, 672. Okay, and then we're going to subtract 32x. So then we have 57, 60 minus 32. 28. Divide this by 28 and x will give you 24. Now while I was doing this, I recall a couple of students mentioning, could we do it this way? Could we do it that way? Is there a different way? Because they see it differently than I do sometimes. And yes, I just want to show you that this could have also been solved part to part. You could have done just a simple x to 32 equals 21 to 28. And then you cross multiply. So 32 times 21 equals 28x. 32 times 21 is 672. And then that takes you again to 24. Now we look at these side to side. Notice that I ended up doing 672 divided by 28 anyways. So to save yourself all these extra steps of distribute, please understand that sometimes a part to part will work. However, sometimes, just to be safe, it's okay to sketch this separately and do it the long way. Okay? All right. The next problem we have, use the following triangles to answer the questions on the right. So the question says, what is the ratio of CA to DO? CA to DO. So you're just going to write 15 to 18, or you could write 5 to 6 if you simplify it. If you divide this by 3 on both, you get 5 and 6. What is the scale factor of CAT to DOG? Triangle CAT to DOG. So the scale factor is we go from one to another, CAT to DOG. So because it's going CAT to DOG, you're going to just use the numbers, corresponding numbers, and write it again. One thing you're going to notice is that they should be the same. These two. They should be the same. The ratio and the scale factor. So now what is the perimeter for CAT, triangle CAT? So they're giving you all 3 sides for the big one. So I believe this is similar to what we were doing earlier. Let's go ahead and add all these sides. And here we're going to get 14, 54. So we're going to write a perimeter of the small one over the perimeter of the big one, which is 54, equals, and then you use the ratio, which is 5 to 6, 5 being the smallest, so 5 to 6, because the small is on the top, big is on the bottom. And then this will be used to find the perimeter. 54 times 5 equals 6p. 54 times 5 is 270. And you divide by 6, p equals 45. This video is for you to just verify that you're doing the work correctly. So please, again, if this is too fast for you, pause the video, try it on your own, rewind, whatever you have to do to understand what just happened. All right, last question on Unit 5. We have the similarity theorems. We have to check if they're similar or not and why. So this first one, determine if each of the followings are similar. If they are, write the rule. We have 3 sides given on this one. So we have to compare if they are going to be corresponding to each other. The trick here is making sure we do the correct corresponding sides. So we can tell if these two correspond just by looking at the sketch. And then as far as the other two, we can tell that 12 is smaller than 16, just like 7 is smaller than 10. So these are the corresponding sides right there. And then this two right here. So we're going to write proportion, comparing all 3 sides. We can do 5 to 4 should be equal to 12 to 7. And then we can do should be equal to 16 to 10. So when we do this, we can either divide these individually, one at a time, and then just check if they're equal to each other, or we could type them 2 at a time and press enter and see if they're equal to each other. I will just do individually, one at a time. I'm going to turn that into decimal, and that's 1.25. 12 divided by 7, and that's 1.7. And then 16 divided by 10, that's 1.6. So all of these, when they're decimal, they're definitely not equal. So we're going to say we're not similar. Okay, next, B, it says we have an angle right here shaded as congruent. It is in between the 2 sides that are being marked. That's what you want to say if you consider side angle side. However, we need to check that the sides are proportional. So if we compare them, we're going to say 50 seems to be going with 35, and then the other two. So we're going to do 50 to 35 equals 45 to 31.5. If you type this in a calculator together, it'll just tell you yes or no. So that's true. But in case you don't want to type them together, I'm just going to do them individually, show you the decimal version of them. So they're the same decimal. All right, so we can officially say that this side angle side similarity theorem is what follows. On letter C, we have no angles being shown, so it's just sides. So we're going to check if these sides are proportional to each other. So we can say side, side, side. So here, again, color coordinating for you. We're going to say 9 and 14 are the corresponding sides. And then we have this long stretch corresponding to that. And this one, the dot. So we're going to write 9 to 14 equals 13.5 to 21 equals 20.25 to 31.5. And then we're going to check 9 divided by 14, that's 0.64. So 0.64. And then 13.5 divided by 21, that's the same decimal. So now let's check the last one. And 0.64, they're all the same. So yes, this is backed up proportionally that the side, side, side similarity theorem identifies it. All right, last question for Unit 5. We have two angles, 90 degree and 39 given. Over here we have 90 degree and 51 given. So since they're not the same right here, 39, 51, we need to check if this third side could be 51 or if this third side could be 39. So what we can do is 180 minus 90, which we already know is 90. So these two need to add up to 90. If this is 90 plus 90, that's 180. So 39 and 51. If you add those, does that give you 90? Looks like it. And then same thing applies here. 39, 51, that's 90. So yes, this is backed up that it is angle theorem, backing up that they are similar. All right, watch the other videos if you want to review the other units. Hope this helps you.